orthographic drawing projection. Okay, so it's gonna be like just one question. Okay, the duration of the test is gonna be like 2.5 hours. I believe we're gonna start at 8 and probably it's gonna end at 10:30. Okay, so please be prepared for your test too. And then the week after that, there's like the whole week that you can concentrate on finishing your mini project. Okay, so the due date of the submission of your mini project, that means the report and also all the drawings. Okay, for the mini project, please submit your report, your drawings, all your data in the .dwg, that means the AutoCAD files drawing for each and every component, the exploded drawing and assembly drawing. Okay, I believe you can go through the mini project guidelines. There's they list out a very details about what you need to put in your report. Okay, and also I believe you have to prepare for your video presentation as well. Okay, if you're not familiar with whatever software that you can use to prepare your video presentation, I think the least that you can do is just like prepare like a PowerPoint slide and then add on your voiceover on that. That's the least that you can do. Use a PowerPoint slide and then just add your voice explaining about what you do with your project. Okay, so I believe the due date for your mini project is going to be on 25th of June. Okay, that is on, I believe it's on Friday. Okay, yeah, it's on Friday, 25th of June. So that means before the start of the study break for this semester, you're done with this course, okay? There's no final exam during the study week. You can concentrate on other subjects, okay? So by 25th of June, you're done with this course, okay? So I believe that's the tentative for this course for this semester. I believe we missed like some weeks due to some circumstances that we cannot avoid, but okay, it is what it is. So if you have any question, you can ask in Yulen, or if possible, you can just email me directly. Okay, especially regarding the project. Okay, if you need further clarification about what you need to put in your report or something like that. So for those who just joined the class, please write down your name, your matrix number, and your session in the chat box as a proof of your attendance. Let's look how many. Okay, it's like 54 participants. That means 50 students. All right. Okay, so for today, we're gonna continue with what we have left before. Okay, let me share my AutoCAD. Okay, so I believe for this week, what I'm gonna explain is about what is the other function that we have in this modeling ribbons, and then some of the solid editing, and also probably a little bit of the modify function that you can use when you produce a 3D drawing. But for the question for your test next week, I believe based on whatever I already explained in the previous lecture, you can do the test, okay? But for this week, it's just like an additional function that you can like learn and probably apply it when you do your mini project, okay? Because for your mini project, you have more like I believe a more complicated type of shapes of 3D object that you need to construct. So you can use this function. Okay, so okay, let's start. Okay, so I believe last previous lecture we already learned, I already explained about the function of the basic shape that you can construct using AutoCAD. But for this week, we're gonna go through this like another function still under the modeling ribbons. Okay. Previously, we just what I'm gonna explain. We just use like a press pull function in order for you to like construct a 3D object based on a 2D geometric drawing. But there's also other function that you can use. For example, in here, extrude. Okay. I believe you know what the extrude means. Okay. For example, if you have like a some kind of a geometric drawing like this, okay, you can either use press pull, okay, or if you use extrude, it's going to produce the same thing, okay. But yeah, if you use extrude, okay, you have to select, if you construct the geometric drawing, it's like a individual geometric drawing, you have to select everything. Okay, you have to select everything. For example, if you select extrude, you just select one line, it's just gonna construct like a wall, right? Because it's just detect one thing. Okay, so the best thing sometimes in some application you need to use extrude. It's much more easier than the press pull. Okay, so my practice is when I want to use this kind of drawing, even when I want to use a press pull function, I always advise my students to, if I have like an individual lines like this, please join the lines to become one. Properties, okay, we go to join, select everything, press enter on your keyboard. Now everything is one properties. So that when you extrude it, okay, you can simply click the lines and then you can enter the amount of the height of the extrusion. The difference between press pull and extrude, for extrude, you have to select on the line, right? On the line, okay? Exactly on the line. But if you use the function of press pull, you cannot select on the line. Normally we select in between because for the function of press pull, you don't have to join the lines. If it's individual line, you can still use the function of press pull as long as it is an enclosed shape or enclosed geometry. It should be okay. Okay, but for extrude, you have to the geometry drawing must be like one property. It's one line, and then you click on the line, press enter on your keyboard, then you can specify the height. For example, 20. Okay, something like that. Okay, and then one more thing is, for example, if I have some kind of like geometry like this, right, and then I have a circle, right? If I use the function of press pull, this is just I want to explain the difference between press pull and extrude. For the press pull, if you select this geometry drawing, you move your cursor or your mouse so that it detects everything. Once you click it, it's straight away going to construct an object with a solid, and then in the middle, the geometry in the middle, for example, for this example is the circle, is going to become a hollow, right? But it's not the case for extrude. Extrude cannot do that. It's just going to extrude the geometry. If you click extrude, you click the lines, okay? It's just, you have to select both, okay? I believe if you look in here, it's gonna look like that. It doesn't produce like a hollow in the middle. It's just produce another solid object, okay? It's just produce another solid object. Okay, that's why I prefer sometimes to use a function of press pull. It makes my job a bit faster. Okay, but for let me try to delete it back. But for the function of extrude, basically, if you click extrude, okay, and then you select the object to extrude, okay, you press enter on your keyboard, there is like a additional function that you have in here. For example, direction, path, taper, angle. Sometimes I use, if you want the extrusion to have a certain angle, you can use a function of taper angle. For example, in here, okay, you want to have like a taper angle. Okay, if 0 degrees, there is no angle. If, for example, my taper angle is 30 degrees, okay, it will construct like a extrusion of the object of the base geometrical object with some angle of extrusion. Okay, then you specify the height. For example, my height is 5, something like that. Okay, if you want a certain angle, this angle you can play around with it. Okay, you can put whatever amount of angle that you want it. Okay, so that's the additional function that you normally use when you use a function of extrude. Okay, it's very simple. Okay, if you want to have additional explanation about the function, just move your cursor and leave it at whatever uh, icon of the function it is. Then it's going to provide like a box, explain a bit more about the function as well. Okay, okay. Then if you click the small arrow under the function of extrude there, okay, there's a loft, revolve, and sweep. Okay, what is loft? Okay, loft means if you have a like a some cross section, geometrical cross section, okay, you can create a object based on that section. For example, okay, for example, if I have like a circle, just want to open another here. Okay. For example, if I have like a circle with a radius of 10, for example, okay, then the same circle, I have another circle at the same geometry, for example, radius of 5 and also radius of 20, for example, like this. Okay, then I just want to move this one from here going up like that. Okay, and then from here it's going, for example, like this. If I have like a three different cross section, I want to construct an object based on this cross section. Okay, that's how we can use the function of loft. Okay, when you click loft, okay, this is going to ask you in the command bar, loft select cross section in lofting order. For example, in here, I start with here, and then I'll go here, and then I go here. After I'm done with it, I press enter. Okay. Oops. Here, here. Cross section only. Yes. Okay. So the end product is going to look like this. Okay. That means it's going to construct like a object based on this cross section. I have three different types of circles with different radius. First one in the middle, at the bottom, in the middle, at the top. Okay. So it's going to produce a shape like this. Okay. Let me undo it back. But the function of loft, it depends on the lofting order. For example, if I change the order, okay, I click loft, I start with the bottom, the second one the top, and then the third one is the middle. Okay. So what they're going to produce is a totally different types of 3D object. Okay. So this 3D object is basically, if you use the function of loft, it depends on the order of your lofting procedure. Okay, that you have to be very careful, or you have to know what kind of shape you want to draw. Okay, and then you can use this kind of function. Okay, that's for loft. Okay, and then we go, basically that's for loft. Okay, basically you can construct a 3D object based on cross section. Okay, you have the different cross section at different plane, and then you can use the function of loft. And then after you extrude, loft, and revolve, okay, what is revolve? Okay, revolve means let me open the this is here for me. Revolve means that you have a certain geometry, and then that geometry you want to construct a 3D object based on the geometry, but it's going to revolve around some kind of reference axis. For example, if I have a certain kind of line like this, right? Okay, this geometry, okay, if you look at this geometry, I want to construct a 3D object based on this geometry, but it revolves on certain reference line. For example, if I have a line like this, okay, so this geometry gonna rotate around this reference line to construct a 3D object. That's how the function loft works. Okay, so if you click loft, and I'm gonna ask you, it's not loft, revolve, revolve. You click revolve, select object to revolve. This is my object. Enter, and then specify axis point. Okay, this is my axis of rotation from here to here. So as you can see, it's going to rotate, and the rotation as a default is going to be 360 degrees, but you can change it. Okay, for example, if I just want it to rotate half of it, 180, I can do that. Okay, so this is the product. Where is my navigation bar? Okay, something like that. Okay, but if I want to make it full, then I can do that. Evolve, and then okay, this is one more thing that I need to explain. If you click revolve, okay, select object or mode, okay, you can either create a solid or just a surface like we used before. If I want to create a solid, and then I select solid, and then this is the object, press enter on my keyboard, and then I select the reference line from here to here, for example. Okay, if 360, okay, so that's how we're going to construct for you. Okay, that's the shape. Okay, so for revolve, that means you involve like a rotation, right? You want to rotate, you want to construct a 3D object based on geometrical drawing, geometrical lines or profiles, and then based on that profile, you want to rotate it based on some kind of reference line. Okay, that's how this function of revolve works. Okay, you can change it whether either you want it to become like a solid or just a surface. Okay, sometimes we need just a surface, not a fully solid 3D object. But I believe for this class, mostly you're gonna use a solid, right? Okay, then go back to this. Gonna go to the last function. That is like a sweep. Okay, sweep means like this. You can see if I left my cursor in here. That means you have like a certain it's like a it's like the opposite of the revolve. Okay, the revolve mostly the more complicated like a profile is the profile that you want to construct the object on. Okay, and then it's just based on like a one straight reference line, and then it's going to rotate against that reference line. The more complicated geometry is the object that you want to like construct. But the difference for sweep. For sweep, basically, normally the object or the geometry that you want to produce is like a simple geometry. But the geometry is going to be like a constructed along the what we call a sweeping profile. Okay, for example, if you want to construct like a spring like this, okay, we can try that. Okay, so what we need is basically is one is the profile that or the geometrical drawing that you want to sweep, you want to construct, and then like a sweeping path. Okay, you need to construct that one too. Okay, if for example I want to construct the spring like they mentioned in here, so for the sweeping path, what I can do is I can use this function of helix, right? Put the helix. Okay, this is the center of the base. For example, if the base is 5, okay, can you see? Oh, I know. Top radius is gonna be 5, and then the height is gonna be, I gonna more, I just gonna be 10, for example. Okay, so I have like a path like this, right? This is my sweeping path. Then I need to construct like an object, like a geometrical object that I want to construct along the sweeping path. Okay, so for the spring, if for example I want to construct a spring, the geometrical object for the spring is just a circle. What I can do is probably I can just move this in here, and then something like that, and then I can just simply, oh no, again I have to change, right, this one to become some kind of XY plane. Okay, so for sweep, what you need to pay attention is that uh, the plane, the orientation of the sweeping path and also the object cannot be on exactly on the same plane. It must have like a certain angle. Okay, it doesn't matter. Uh, the angle must be a bit different. Okay, if it's exactly on the same plane, it's not be able to construct the sweeping function. For example, if I have like a circle in here with the radius of, how much is my radius? So, precision. For example, 0.3, for example. Okay. So I have the sweeping path, and also I have this is the object or geometry that I want to construct along the sweeping path. Okay. Now I can go to modeling, select sweep. It's going to ask me select object to sweep. This is my object I want to sweep. Enter. And then select the sweep path. This is my path. Okay. And then it's done. Then if I want to look at 3D, change my view from 2D wireframe to conceptual, for example. Now you have like a spring, something like that. So basically the function of sweep is kind of opposite of the function of revolve. Okay. Normally for sweep, you use a you use it when you have like a very simple geometrical profile that you want to construct, but the more complicated one is the path, right? But it's opposite to the revolve. The more complicated geometric drawing is the object that you want to construct, but the reference for the object rotation is like it's kind of simple. Okay, so basically that's all the function of modeling that we have, 3D modeling that we have in AutoCAD. Okay, so basically AutoCAD provide like a very simple or basic fundamental of how to construct a 3D object. Okay, it's very limited function basically for a 3D object. Okay, so if you want to construct more 3D object, probably you Yeah, there's some other software that has much better capabilities and also additional function in terms of 3D modeling. But for the simple, not to say a simple, but I believe with the new edition of like the improvement, the AutoCAD version that coming out every year, the the software is adding like more additional capabilities, especially in terms of constructing a 3D object. Okay, right now it's quite okay. Okay, so for you guys, I believe uh, you can still construct a 3D object using a AutoCAD software. Okay, okay. So the other one that I want to explain is basically in the solid editing is just the union, subtract, and also intersect. This is the three function. Also, I believe I also already explained about the extract edges, right? The extract edges, you want to use it a lot. I'm using it a lot, okay? Not some other function in the solid editing. You can play around with it, but I believe for now, you don't need it. But if you are in the process of producing like a more complicated object, then you can go through and play around with this. Okay. So I believe for the solid union, I already explained it. For example, okay, for example, if you have like a oops, if you have like two objects, something like that, right? Okay, I'm gonna extrude this one at the height of, for example, 5, and also this one at the height of 3. Okay, now I have basically two objects, right? So if you click it, one of them, you're going to detect just one by one because we constructed a different object. Okay, so the function of solid in is just to make these two objects to become one. Okay, what you can do is you just click a solid union, select both of the object and press enter on your keyboard. Now this object already become one. There's a solid union. Okay, and then there's also a solid subtract. That means it's going to subtract portion of the object that intersect with the second one. For example, okay, if I select subtract, okay, this is the object I'm selecting. I press enter on my keyboard. This is the object that I want to remove it. Second one. Press enter on my keyboard. Now, as you can see, it's gonna subtract the part that intersect with the object, the second one. Okay, the order must be right. Okay, if, for example, let me undo it back. Okay, if I select solid subtract, the first, when they gonna ask you select object, the first instruction that the AutoCAD gonna ask you is the object that you want to left in your drawing, not the one that you want to remove it. Okay, if I want to select this one, that means this is the one that I want to be in my drawing. After selecting this object, I press enter on my keyboard, and then then the other instruction is going to say select object again, and this is the object that I want to remove it from my object or from my workspace, and then I press enter or make it again. Okay, so the order of the selecting the object is very important. The first one is the object that you want to remove in your drawing. The second one is the portion that you want to remove it from your drawing. Okay, so it's very straightforward. You can try it. Okay, but for this function solid subtract, sometimes I'm not sure why every semester I have like a lot of question about this function solid subtract. Some students say that they cannot use the function. I don't know why, but I'm using it all the time with no problem basically. Okay, so and then there's a function also called solid intersect. Okay, so what the AutoCAD gonna produce is basically they're gonna left you with the only parts that intersect between these two objects. Okay, if I select this solid intersect, they're gonna ask me select object. Okay, this is both my object. I press enter on my keyboard. Now this is only the portion that is intersect between that two objects. This is gonna be the left in my drawing. The other part, they're gonna remove it. Okay, so it's very straightforward. Okay, so solid union, intersect, solid subtract. If you ask me within these three, uh, the function that I mostly use is solid subtract. But sometimes I want to subtract certain part of my drawing, so that's how I do it. Okay. Okay. So, and also, I'm not sure whether it's my elevation bar. Yeah. I'm not sure whether I already explained it in our lecture or not, but we can use the function of fillet. I believe you know, all you guys know what a fillet means, right? That we want to make a curve with a certain radius at like a sharp edges, right? So if, for example, I have this edge, I want to make a fillet around this edge, right? I can still use the function of fillet here. Okay. How do you do it? For example, I click a fillet here, and it asks me to select first object. This is my fillet. This is my object. I just click the edge, okay, the line, the edge there. You're gonna highlight that, and then enter fillet radius. For example, if my fillet radius is 1, I press enter on my keyboard, and then I'm going to select back. They're going to ask me select an edge. Select back this edge, the same edge, and press enter. Oh, it's too big. 1 is too big. The value is too big. So let me repeat it back. Select fillet. You're going to ask me select first object. I'm going to select this edge. I'm going to enter the fillet radius, for example, 0.1. 1 is too big. 0.1. Okay, and then select edge. I'm gonna select this edge again. Press enter. Now it's gonna construct like a fillet in here. Okay, so you can use this function of fillet for whatever edge that you have in your drawing. Okay, okay then. Okay, based on this, let's try do one exercise. Okay, and then based on the exercise, then I'm going to show you guys how do you convert this 3D object into a photographic projection. Okay, let me stop sharing this one first. Okay, because I have to share my screen. It's easier for me to do that. Okay, so let me share my screen. Okay, so for example, if you have this kind of geometry, right? I believe this is one of the exercise that I already give you guys. You can simply do this. For example, if I have this kind of geometry, I want to construct this kind of project. Let's try this. Okay, let's try this. So where should I start? Probably I can just start with this geometry in here until here, right? I can start with that. Okay, so I'm going to change this front view this one to become my XY plane. Okay, then I can construct this geometry 50, 76, going down 15, 38 plus 7, something like that. Okay, okay, draw line from here going switch on my auto mode 50, 50, and then going there is 76, going down 15, and then 45, 45. Then how much is this? Oh, I don't know how much is that, right? So I can do is I can draw a line from here, going there, 30, going up 10, 60, 20. Oops, line going here, and then line from here to going down, something like that. Give it a bit. Okay, this is basically a basic geometry on the side here, right? Then I can use the function of press pull here with the amount of how much is it? It is 60, 60, right? Something like that. Okay, so then I can construct this portion in here. Portion 35 with the radius of 30. Okay, so I can just draw a line from here to here, 35, radius of 30, right? So now I can construct a circle in here, radius of 30, and also diameter of 30, right? Then based on that, I can just simply draw a line from here to there. So I can make this. Okay. So modify trim. Oops. Automated. Oh, no. I'm not sure why they didn't everything. Oh, is it because I didn't select wait, this function? Yes. So I don't want this one. Delete. Okay. So now based on this geometry, I can use function of press pull of this going in with the value of 20. Okay. Then I can just simply go to modify, copy, and copy this object from this, the base point here to here. Right. Now I done with the bottom part, right? If you want to look it in 3D view, basically this is it for the bottom part. Okay. So for the top one, so I need to construct this like a cylinder cylinder here. Okay, so it didn't mention the location of this circle. Basically, I just assume it's going to be in the middle of this plane, plane here. So what I need to do is first I just move my UCS from here, just drag it to be on this plane, right? Now I'm going to change this plane to become my XY plane, my temporary XY plane. Okay, so I know the line in here is 76. If I want the center point of the circle going to be in the middle, so I need to uh, determine the location, or yes, the location of the center point first. Okay, so I just assume it's going to be in the middle because it doesn't mention in the dimension here. So the easiest way is just draw a line from here going there. 76 divided by 2 is going to be 38. Going there, 60 divided by 2 is 30. Right? So the end point of this line is going to be the center point of my circle here. So I have two circles, the diameter of 40 and diameter of 20. So I just go to draw circle, okay, diameter of 40 and also diameter of 20. It's too small. My workspace is too small. No, it looks okay to me. Okay, so just delete this one first. Just delete the line that I just constructed. Because I don't need that line, I just construct it just to become the guide for me to find the location of the center point of the circle. Okay, so go to modeling, press pull, just select this, going up with the amount of 50. Okay. Okay. So now what one that I left is just these ribs, right? So what I need to do is I need to construct like this profile, right? This profile here. Okay, so just so that the first thing first is I need to move my UCS to be in the middle with the amount of 30. Okay. Now I want this plane to become my oops, what's wrong? This plane to become my XY plane. Okay, so 20, 30, 18. Okay, so now what I can do is I can start constructing a line from here. So go to draw line. Okay, line starts at this quadrant here, probably, right? Going there with the value of, how much is it? 20, 38, 18, 18, going down 15, going there 38, then going up quadrant, detecting quadrant here, and then going down here. Okay, so that's the profile. If you want to see it clearly, probably let's change it. Yeah, that's the profile basically. What I can do is I can just simply hide this one first. Okay, so this is the profile, right? The profile that I want to press pull it in order for me to construct this grid. Okay, now go to modeling, press pull, The thickness of this is 10 because the profile is in the middle, so that I can press pull it 5 to the one side and then another 5 to the other side with the amount of 5. And also, let's change to the waveform. This is easy. And then press pull 5 to the other side. Right? So then I'm done. Basically, I'm done constructing this object. I go to back to isolate and object isolation. So this is it, right? This is it. And yeah, I don't think, no, I think we already construct everything. So now, if I want to merge it to become one object, I can use solid union. Select every single one of these. Press enter on my keyboard. Now it becomes one. Okay, normally what I do is I just isolate this all 3D object and then I can just delete all the 2D. So that I just have like just a 3D object in here, not a 2D geometrical drawing anymore. Okay, so based on this 3D object, how do I convert it to become like a orthographic projection? Okay, first of all, I think I already explained about this model layout 1, layout 2, right? So first of all, please get your like a title block. Okay, let me get my title block first. From template, leave. This is the template. Okay, this is the template that we're going to use. Okay, okay. Let me stop sharing my screen. Let me just share back my AutoCAD. It's easier for me. Okay, so this is my title block. Okay, how do you get the title block? I think I already explained it. You just go to this tab here, right? You just right click on your mouse. Let me explain it back. I believe I'm gonna get this question over and over again. Okay, go to one of these like a tab here, right click on your mouse, go to from template. Then from the template, just browse around your computer, okay, just to get just to retrieve where you save your data block. Okay, you can download it from Ulen or the provided it in your own Ulen. You can just use it. Okay, so basically this is the title block. Okay, so how do I convert this 3D object, okay, into here in orthographic projection? Okay, because orthographic projection is the final drawing that we want. Okay, whatever drawing that you do in terms of 3D object or something like that, the main goal is to get to construct a orthographic projection drawing. Okay, so first of all, when you open this title block layout, okay, go to, as you can see here right now, I'm in this home tab, right? So yeah, is there any question? Okay, go to layout tab. Okay, when you click your layout tab, okay, there's like another function in here. Okay, the first step after you click this layout tab is go to this style and standards. Okay, style and standard, there's like a small arrow down there. It's called a drafting standard. Click it. Okay, now you have to choose the projection type, either the first angle or third angle. I will explain about this in my lecture, in our first or second lecture. Okay. Okay. If it doesn't mention anywhere for this course, we're going to use a third angle projection. So change it to become a third angle projection. Okay. If the question wants the first angle, then you choose the first angle. If not, third angle projection. Don't change anything else. Okay. And then press OK. Okay. Then in order for you to create the view is go to this create view ribbons here. Okay. Go to this base. Okay. Click from model space because we want to get the object from this model space. From Inventor. Inventor is another software that from the same developer from Autodesk, you can obtain like an object from Inventor as well. But from here, in AutoCAD, from model space, okay. So the first view that we're going to have here is basically uh, is what we call a parent's view. Okay, the parent's view means this is the reference view. If you click it and then you press enter on your keyboard, you move up, you have like a top view. You move to the right, you have the right hand side view. You move to the left, you have the left hand side view. And you move to the opposite, you have like a 3D object, something like that. This is how we create an orthographic projection based on the 3D object, so that you didn't have to create every single line manually. Okay, and then you can change also the scale in here. Okay, the scale, because you need to put down the scale, right? So how do you change the scale? You basically, the main thing is just change the scale on your parent's view here, and then it's going to change everything. Okay, because if you change in here, if you move here, if you move to the left or right, the top view is going to move as well. The same thing. Okay, if you move bottom, top to bottom, the right hand side view is going to move with your view as well, because this is what we call a parent's view or the reference view. Okay, you can change the scale. Just click this arrow. There's some kind of scale in here. You can choose it. Okay, 1/4. Okay, 1/2, something like that. Okay, if you want to make it bigger, then you can always right, you click this parents object, you double click this view scale, and then you can select this scale here, and then you can just enter the amount. Right now it's on 5, right? Because 1/2, you can change it to on 6. For example, you want to make it a bit bigger, you can do that. Okay, and then please key in your scale in here in your title block as well, because it's very important. So let me change back to 1/2. Okay, and then for this orthographic projection, what is missing is basically the dimension, the center line, and also yeah, that's it. As you can see in circle here, it's supposed to be like a center line, right? In here, on top here, something like that. That's the only thing that's missing. So that you need to construct that. Okay, and also the dimension. Okay, the procedure is going to be the same. Okay, so go back to the home tab in here. Okay, so now I'm not sure whether I have a layer or not. Okay, probably I need to create like a layer for center line, for example. Layer 1, change it to center line. Okay, why? Because I want it to be like a different types of line type, right? So the center line is gonna be load. We're gonna use a dash dot, right? Dash dot. Okay, dash dot. This is gonna be my center line. Wait, basically. Wait a minute. I need to change my laptop. Okay, so the next layer that I want to create is basically a dimension layer, right? Dimension. So it's going to be a red as well, but it's going to be like a solid line. So let's see. Okay. So for layer, I want to construct my center line. I go to my center line layer, and then I can just simply construct a line from here to here. Okay. Even though it's a dash dot, but as you can see, because the scale of the line is too big, it looks like a straight line. What you can do is change the line type scale, LTS, line type scale, and I can change it to make it smaller, for example, 0.2. Okay, 0.2. Now you can see the dash dot, right? Okay, now I can go back and construct this kind of line here. Something like that. Okay. So the one that is missing when you construct this orthographic projection is basically the center line also there. And also the, what we call it, the dimension. Okay, so the other one is in here, same thing. Line from here to here, so line from here to here. And also, I'm just going to construct a line from here to here, and from here to here, right? And also, line from here to here. What else? From here to here. It's okay. It's supposed to be like a line from here to here as well. Line from here to here. Going down a bit. Switch off my snack mode. Something like that. Right? So basically that's the center line that I need to produce. Okay. So for your test piece, you have to do this. Okay. If not, your drawing is not going to be considered like a complete drawing. Okay. So normally for this 3D object, it's not here. This is not like a formal practice. Okay. Normally for the first quadrant, it's just like a projection lines, right? In this first quadrant, we use the first quadrant as our projection quadrant. But it becomes like a practice nowadays that in the first quadrant, instead of it left blank in there, they put the object, 3D object in there. just to give some kind of visualization of what this orthographic projection object looks like in 3D. Okay, so we can change this. Instead of using 2D wireframe, you can double click it. Okay, instead of its hidden lines here, you go back on top